Hello. Today we will learn the bitwise operators in Python. Okay, how bitwise operators are used and what are the bitwise operators. Okay, first let us see what are the bitwise operators. Okay, this is called bitwise AND, the symbol. Okay, see we used write AND before. That AND is logical AND. Okay, you can't write bitwise, you can write AND. It's I'm just writing how to pronounce it. This is OR. This is exclusive OR. Okay, right shift, left shift and inversion. In these six operators, the last one is a unary. They require only single operand. The remaining all require two operands. The remaining all require what? Two operands. Okay. Now, why they are called as bitwise operators? Because they are going to manipulate the bits of the variable. Bits of the variable. Okay. Let us see how it is. So first is we said what? Bitwise AND, bitwise OR, exclusive OR, right shift, left shift, and what we said what inversion, right? And in that we said this is a unary, this is all binary. What do you mean by binary? They require two operands. Okay, let us see here in this cases how the AND works. Okay, let us see here in this cases my x is right now 24, y is right now 17. Now in this case what is stored in x is the binary form of 24 is stored. Binary form of 24 is stored, right? Let's see how to get the binary form of 24. We'll divide this by 2. How much will become 12 and the remainder is 0. 6 it is 0. 3 it is 0. 1 its remainder is 1 and 0. 3 divided by 2 quotient is 1, remainder is 1. Okay. 1 divided by 2 quotient is 0, remainder is what? 1. Therefore, the binary form of 24 is 1 1 0 0 0. If you don't know how to get the binary form, please watch the previous lecture, the number system. Yeah. Now, this is only 5 bits. X is an integer. Integer means 4 bytes. 4 bytes will have what? 4 bytes will have a 32 bits. Here only filled with what? 5 bits. The remaining all will be filled with zeros. All will be filled with what? If the first bit is the sign bit, if the sign bit is 0 means the number is positive number. Remember, if the sign bit is 1 means the number is what? A negative number. There are 32 bits are there here. Okay. Now 17. How to get the binary form of 17 here? 17 divided by 2. How much I'll get what in this case? 8 2s are 16. Remainder is what? 1. Then we have a 4. Remainder is what? 0. 2. Remainder is 0. 1. Remainder is 0. 0. Remainder is what? 1. Therefore, it's going to be again, is going to be what? Total 5 bit. This one should be here. Huh? Remember 1. And this 0 is here. And then we have a 0. 0 and 1. Remaining all bits are filled with what? Zeros. Okay. If I say here in this case x and y, what will happen? X and y. If I write x and y, the bits of x and y is going to interact. How it's going to get a value for me? And means both of them should be 1. Okay. 0 and 1 would be 0. 0 and 0 would be 0. 0 and 0 would be 0. 0 and 1. And the remaining all what? Zeros. What is the value right now? What is the value I'm going to get it? If I say this is 2 raised to 0, this is 2 raised to 1, 2 raised to 2, 2 raised to 3. 2 raised to 4 into 1. 2 raised to 4 into 1 is how much you'll get what? 16. Therefore, the result of this operation is going to be what? 16. What would be x or y? If I write x or y, any one of the bit needs to be what? Any one of the bit needs to be 1 here. Okay. Any one of the bit needs to be 1. Okay. In this case, what will happen? 0 or 1 would be 1, 0, 0, 1 and 1. Remaining all will be filled with what? Zeros. Why? Because 0 or 0 is 0. What is the answer I'm going to get? This is 2 raised to 0, 2 raised to 1, 2, 2 raised to 3 and 2 raised to 4. 2 raised to 4 is how much it is what? 16. 16 plus 2 raised to 3 is 8. That is 24 plus 1 is what? 25. Now x or x exclusive or means what will happen? X exclusive y what will happen? If x exclusive y means both of them should not be same. If both of them are same, result is 0. Okay, 0 or 1 would be 1 and 0 or 0 would be what? 0, 0. 1 or this is 1 and this will be what? 0. Why? Because both are 1. If both are 1, both are 0, result is 0. If one of them should be what? 1 here. In this case, what will happen? This is 2 raised to 0, 2 raised to 1, 2 and 3. This is 8, 8 plus 1 is what? 9 I should say. When you want to verify it, make sure that you can verify easily. The sum of and exclusive OR will become OR. 16 plus 9 is what? 25. Why? Because in AND you take only both the ones. In OR, in exclusive OR, what you do? You reject both the ones. Whereas in OR, what you do? You include everything. You include what? Everything. Okay. Now, if I say right now in this case X, right shift 2, right, like the right shift 3, let's say right shift 3, what will happen? If I say X right shift 3, what you do? First is write the binary form of X. Binary form of X, you write it. Okay. Right shift 3 means what to do in this case is you have to remove 3 bits on the right hand side. Remove 3 bits on the right hand side. If I remove 3 bits on the right hand side, what will happen? 1, 2, 3 will be knocked out. Add that many zeros on the left hand side. How many? Whatever you remove doesn't matter. Here you could have removed 1 also, but you have to always add what? Zeros here. Okay. Whatever you remove, but you will always add what? 0 here. Okay. Now, what is the answer I'm going to get? This is 2 raised to 0 and 2 raised to 1. That means 2 raised to 1 is how much I'll get what? 2. 2 plus 1 is what? 3 and 1. Okay. Now, if I say here X left shift, if I say X left shift, what will happen? I've written here X left shift. What is going to happen here? You have to write the binary form of X first. What is the binary form of X? 0, 0, 0 and 0, 0, 0, 1, 1, 0, 0. Left shift 2 means remove 2 bits from the left hand side, add that many zeros on the right hand. 2. Okay. Now that means this is 2 raised to 0, 2 raised to 1, 2, 3, 4, and 2 raised to 5, and 2 raised to 6. 2 raised to 6 is 64 plus 32. How much will get what in this case is 64 plus 32 is what? 90. Correct? Now, if I say here in this case, inversion of X, what will happen? If I say inversion of X means what will happen here? First is you need to find the binary form of X first. Binary form of X needs to be returned. Remember, you need to write 32 bits. Okay. What is the result of inversion of X is going to be? Every bit needs to be reversed. This is 1, 1, 1. And this is 1, 1, 1, 0, 0, 1, 1, 1. Now, what is the value? The value you cannot calculate like this. This is 2 raised to 0, 2 raised to 1, 2 raised to 2. Why? Because if the first bit is the sign bit is 1 means what you need to do first is here, in order to get a value, if the sign bit is 1 means in order to get a value, what you have to do first is what you need to do here, you need to what? Inverse the bits and subtract 2. Okay, now inverse the bits and what? Subtract 1. You need to subtract 1 and inverse the bit. Subtract 1 and what? Inverse the bit. Subtract 1 and what? Inverse the bit. Okay, done. 1 minus 1 is what? 0. 1, 1, 0, 0. This, and subtracted 1. Okay. After subtracting 1, what you should do? Inverse the bits. If you inverse the bits, what will happen? 0, 0, 0, 0, 0. 1, 1, 0, 0, 1. Now what will happen for you? What right now? What is the value? Sign bit is 0 right now, correct? Therefore, now you can calculate like this. 2 raised to 0, 2 raised to 1, 2, 3, 4. That means this is 2 raised to 0 into 1, 2 and 2 raised to what? This is 2 raised to 3 and 2 raised to 4. 16 plus 8 is what? 24. 24 plus 1 is what? 25. But you have did this procedure because the number was negative, right? Therefore, you have to put minus 25. Minus what? 25. Okay. So, the inversion will do what? Inverse all the bits. Once inverse all the bits, you need to see the sign bit. If the sign bit is 1, means what you have to do here? You need to subtract 1 and inverse the bits so that it become positive. Once it become positive, you need to calculate directly. After calculating, what you need to do here? Since it is you converted this procedure, you will add a sign bit. Okay. A simple thing for you, okay, but if not, you should not learn like this. You should know how it's happening. If the number is positive, inversion will make negative and add 1 to it. We have 24, inversion made it a negative and add 1 to it. 1 to means what? How much will get what? Minus 20. Now, if the number is negative, inversion will make it positive. That means what we'll do here? Inversion will make it. Now, if it is minus 25, inversion here, what will happen? It will become what in this case is? This will become positive and 1 you need to subtract from here. It will become positive. Okay. I hope you understand. Yeah. Got it? Okay. So just let me check with you. If I put my X is right now, X is 75. Inversion of X will become minus 76. If my X is minus 76, inversion of X will become 75. Okay. One more thing for you, okay, to understand better, okay. Now look at this. You have right now right shift, okay. If you look at this right shift, what the right shift does, okay, by removing 1 0 on the right hand side, you are dividing a number by 2, okay. You have divided the number by 2. How many times you divided the number by 2? What? 3 times. Why you did that? What was the number was 24, right? 24 was my number. You divide by 2 3 times. Therefore, it will become 24 by 2 is 12. 12 by 2 is what? 6. 6 by 2 is what? 3. Left shift is for multiplying a number by 2 that many times. What you have to do? 24 needs to be multiplied by 2. Why? Because 24 into 2 is 48. 48 into 2 is what? 96. Okay. It's a shortcut for you to remember. Okay. But you should know how it's happening actually. How it's happening, you should know. Okay. Right. So let us see whether what I said is right or wrong. Let's see here in this case, we'll understand. Okay. X is 24. Y is what? 17. Let's compile and see. So we have X is what? 24. Right. Y is how much was? 17. Okay, you can put and see verify. So if I say print X and Y, okay, what is the output set? What? X and Y should have what? 16, right? Now if I say X, okay, so I'm going to put all of them in one go so you understand everything, but make sure that X or Y, what will be X or Y would be, we said what? 25. Yeah. Now print X exclusive Y. How much we said what? 9, because sum of this should be this, right? Now we said X. They are producing integer. Okay, you can store it in a variable. I just am printing and showing you. X right shift what? 3. We had 3. X left shift what? X left shift 2. Right? 96. Multiply by 2 that many times. Print inversion of X will give you what? Minus 25, right? That's what we said. Okay. Now you must ask why we are using this. Okay. The bitwise operators, if you know how to solve problem using bitwise operator, your program will run faster. Okay. Now, if you say when I multiply a number by 2, it may x into 2, you may look very okay, it's very easy, right? But for the computer, it takes a longer time to do that. Okay, as you know, further, if you study computer science, you'll understand. But here, if you say x right, if I want to multiply by 2, I can say x right shift what? X left shift 2. If I write it, it's only bits, 2 bits only it shifts here. In this case, the faster the multiplication. Okay, so let us take one problem also, then we'll understand. Okay, now I'm going to give you a problem and how to use a bitwise operators and get the answer here. Okay, so let us see here in this cases. I have been given a number. Okay, let's say I've been given a number 24. Okay, 24 is given. This is what the number is. The binary form of 24 is this, right? Now I need to extract what is there in the fourth bit. What is there in the fourth bit right now? 1. Correct now. 1 is there. How to get this 1 on this? Okay, how to get this 1? I want the fourth bit. Okay, simple thing. What do you do in this case is see, if you say now you want the fourth bit, right? Therefore, what I'm going to do here first is this is the binary form of 1100, right? Now 1100, and the rest of the bits are what? 0. Right? Now you want the fourth bit, correct? Now, if you want the fourth bit, what do you do? Remove these 3 bits first. How will remove these 3 bits? X right shift 3. This 3 will go. Correct? Now that means this bit becomes the first bit. Now, and obviously these are filled with zeros. Now what do you do? With this result, you want 1, right? Simply say here in this case and 1. And 1 means what? Binary form of 1 is this. Okay, so what happens? Both are 1. Therefore, what will happen? The result is 1. If it would have been 0 here, what would happen? I will get 0. That's it. I'll get what? 0. Simple thing. Yeah? So let us see here. Okay, now let's see. What do we wanted? What is there on the fourth bit? Fourth bit means I have to extract the 3 bits out. So if I want the nth bit, n is let's say 4. So what do you do first? N is 4. Yeah. What I need to do, what we said was x what? Cut 3 bits. How to cut 3 bits? N minus 1. After cutting 3 bits, what do you do? And 1 cut That's it, over. And you get the answer. What's the answer I got? 1. Okay, now the 1 is the answer. Let's say what was our in the third bit? 0, correct now? So that means if I apply the same thing, what will happen to me? Okay, just avoid confusion. Third bit. Now I cut 2 bits out. I get what? 0. Yeah. I want to find whether the number is odd or even. Yeah, this what. If you want to find the number is odd or even, what do you need to do? The first bit needs to be, if the first bit is 1 means what, number is what, odd. If first bit is 0 means number is what, even, right? So simply write here. You want that odd or even, right? X and 1. If the 1 x binary form of x, if the last bit is 0, 0 and 1 will produce what? 0. 1 and 1 will produce what? It is what? Even. If you use odd, how to find out if it's odd? Put 25 and see. Got it? Yeah. Okay, this is the bitwise operators. As we go, I think probably if you are in the computer science, if you can see and all, if you study, you will exclusively use these operators. Okay, yeah, I hope you understand. Okay, thank you so much.